National 5 Chemistry. Final revision for all three units. This is the last little bit to have going. If you listen to this, you're probably getting a little bit worried. 1. Reaction rate. This is collision theory. Particles have to collide with enough energy to react. We increase the energy, i.e. increase the temp, reaction increases. Increase the concentration, more particles with the energy, reaction increases. Increase the surface area, same idea. And a catalyst allows it to do it in a different way. Enzymes are biological catalysts. Reaction rate is the change in the product divided by the change in the time. Reaction rate graphs. Steeper the graph, the faster the reaction. Shallower the graph, the slower. If we're only using half the mass of one of the reactants, we'll only produce half the product. And when the graph line goes flat, that is when the reaction has finished. You get 4 marks for the graph, 2 of them for reading something. Stupid not to do them. Atomic structure, you need to know the parts of an atom, as in the table there, where they are. You also need to understand that an atom is neutral because protons equal electrons, positives equals negatives. You need to be able to use nuclide notation, i.e. the symbol. The big number is atomic mass, protons plus neutrons. Small number is the number of protons, it never changes. The atom could have a charge if you've lost electrons or not, and the number of electrons is given at the bottom. Isotopes, same atomic number, different atomic mass, i.e. there's more more neutrons there. You can see from the 2 examples given, the average atomic mass, if it's 80 in the first one, it means it's 50-50 of each. If it's 23 in the second one, 23.1, it means most of it is 23. Ions are where electrons have been lost if it's a metal, so it becomes positive, more protons, or negative if it's a non-metal. Bonding, ionic, non-metal to metal, high melting point. The reason it conducts as a liquid is the ions can move, not as a solid though. Covalent network, non-metal to non-metal, high, it doesn't conduct at all. Covalent molecular, non-metal to non-metal, low, due to intermolecular bonding, doesn't conduct. And metallic, metals, high, conduct because the electrons are free to move. The definitions are given at the bottom, they don't change. The description for each bonding is, if it's one-on-one, it's going to be straight, it's going to be linear. If it's H2O, H2S, it's going to be angular. If there's 3-to-1 for the second one, pH3, CH3, whatever, it's going to be trinormal pyramidal. And CH4, tetrahedral. You can see from the outer electrons, if you're asked to draw outer electron diagrams, it is just outer electrons that's required. Always draw the central atom first before the outer one. That's going to be seen here. Formulae. IDE, 2 elements, ITE, ATE, 2 elements plus oxygen. Non-metal formulas, mon, di, tri, will give you the number of that atom that is there. And the valence formula. Use the valence formula for majority of things that you're going to come across. The valence formula involves the swapping of the valences. Calculations. The first part of any calculation is to work out the gram formula mass. Add up the weights of all the elements. A mole is the gram formula mass as grams. So 142 grams for sodium sulfate there. The 2 triangles you're given. One is for if we're talking liquids, so it mentions concentrations and volumes. One is we're talking masses, so we've got mass and gram formula mass. Cover up what you're looking for with your thumb. That will give you the formula then for what's remaining. Here's an example of how to use the triangles and how to lay things out if you're asked for a mass or a volume or a number of moles from a given equation. You also need to balance equations. What this means is making sure you have the same number of each element on each side of the arrow without altering any of the formulas that you are given. You can put numbers in front, but you cannot change the formula. Another piece of maths you will have to do is the percent composition. So this could be done for them in the metals topic, it could be done in the fertilizers topic, but the general idea is that you're looking for the percent, in this case of iron, in iron sulfate. So it's iron plus divided by the mass of iron sulfate times by 100 equals. Acids and alkalis. Acids, non-metal oxides. H plus ions are greater than OH minus ions, pH 1 to 6. Strong ones, as you can see in there, weak ones, as you can see there. Neutral. H plus equals OH minus, pH is 7, neutral. Water. And alkalis, H plus is less than the OH minuses, pH of 8 to 14, as you can see the colours. And weak ones are sodium bicarb, strong ones are sodium hydroxide and calcium hydroxide. Indicators are used to show the endpoint, and neutralization is when the acid rises towards 7 or the alkali falls towards 7. Hydrochloric acid gives chloride salts, nitric nitrate salts, sulfuric sulfate, ethanoic ethanoate. Soluble salts should filter to remove any reactants, evaporate to leave the salt. Insoluble salts filter to obtain the salt as a precipitate. There's a lot to remember for this is Unit 2, hydrocarbons. And as you can see, you need to remember the first 8 names and the fact that it's a double bond there, it's going to finish "ene". Okay? You need to remember the generic formulas, as well as a homogeneous series, same general formula, different and similar chemical properties. All of the above needs to be in your mind. When naming the things, as I said before, backside first. Look to see if there's a double bond there. If there's a double bond there, it's going to finish "ene". If there's not, it's going to finish "ane". You then look for the longest carbon chain, meth, eth, or whatever. And then look for what groups might be attached. A methane group becomes a methyl group. And then you put on the number of the carbon that it's on to give the lowest possible number possible. An isomer has the same molecular formula but a different structural formula. You need to know about alcohols, hydroxyl unit finishing "ol", so ethane becomes ethanol. Carboxylic acids, these finish with an ethanoic group, a carboxyl group, and these become anoic acids, ethanoic acid. Usual reactions for acids, they form salts, which are anoates. Energy in fuels, EH equals Cm delta T. All the material for that is given at the start of the data. Unit 3 starts with metals. Again, there's a lot of information here, and all you can do is try and learn it. Extraction is, as I said, remember, page 10 of the data book, there's what's called the electrochemical series. Reactive ones are at the top, non-reactive ones are at the bottom. Just need to learn this material. There's not much else we can do about that. The diagrams here show what will happen when we make up simple cells. Electrons will flow through the wire from the higher reactivity material, magnesium, to the lower. The bigger the difference between the two metals, the bigger the electricity generated, and it's ions that flow through the liquid rather than electrons. So electrons through wires, ions through liquid. Into the home straight. Polymers. These are made from monomers, poly many, mono one. So ethene becomes polyethene. You'll be asked to draw 3 units of it, or find out the monomer from the 3 units. If you're asked to find out the monomer, then you put the double bond back in. This is an example of addition polymerization. Fertilizers. This is the Haber process. You need to know the 3 things for fertilizers: nitrogen, phosphorus, potassium. You need to know that how ammonia is made in the equation. So N2 plus 3H2 will give you 2HN3, H83, which is the Haber process. It's reversible. To turn ammonia into nitric acid, use the Ostwald process. Things you need to remember from this: Haber process, ammonia, iron catalyst; Ostwald process, nitric acid, platinum catalyst. Nuclear chemistry. 3 types of radiation you need: alpha, which will be stopped by paper, and it's a helium nucleus, as you can see there. Beta, which will be stopped by aluminium, and it's an electron. Gamma, which will be stopped by lead. but it's not a particle, so there's no charge on it. Alpha radiation, atomic number loses 2, atomic mass loses 4. Beta radiation, atomic number gains 1, atomic mass doesn't change, and there's no change for gamma radiation. As far as half-life is concerned, it's the time it takes for half the radiation to disappear. Final bit, this is chemical analysis. There are certain things you need to be able to remember. What a burette is, what a pipette is, how to do a titration, that you don't use the rough titrate, what concordant means, what a standard solution actually is, okay? And the flame test data on page 6 of your data book, as well as other such material, such as the solution data, page whatever, okay?